Hello everybody, we are group number 1 and today we will present our water supply design phase 1 and 2. Firstly, we had the first floor plan, which includes node 2 supplying water to one device and node 3 supplying water to one device. In addition to node 3, there are two subdivisions, node 3.1 supplying water to two devices and node 3.2 providing water to three devices. Totaling 7 devices. Also shown is our cistern with its dimensions, which I will detail later. Secondly, we have the second floor plan, where part of the main pipeline is node 1, supplying water to three devices. In addition to node 1, there are two subdivisions, node 1.1 supplying water to three devices, and node 1.2 providing water to three devices, totaling 9 devices. Therefore, the house has a total of 16 devices. Next, a longitudinal view of the house with a total area with 157.10 square meters. Here, we see the nodes and subnodes mentioned earlier for the maximum probable flow rates of total node 1 and total node 2. A diameter of 3/4 inch was selected for both cases, maintaining velocities within the permissible range and using PVC as the material. Similarly, for total node 3 and a 3/4 inch diameter was selected, maintaining permissible velocities and using PVC as the material. The select type of water reservoir is a cistern, which allows storage and conservation of water for various uses. Assuming a daily allocation of 250 liters per inhabitant with 5 inhabitants, resulting in an average daily flow of 1,250 liters and a total volume of 1.25 cubic meters. The cistern dimensions are 1 meter per 1 meter, holding 1 meter 25 meters of water with an additional 0.3 meters of freeboard, resulting in a total cistern height of 1.25 meters.
After that, we are going to calculate our water supply systems. The first of this is the suction. For this, we're going to need the maximal probable flow rate. That is a theoretical value. And we need the flow rate, diameter, velocity, and friction-based losses from Flamand's tables. After that, we need the horizontal and vertical length from our cistern to the pump that we get here. We are also gonna calculate the equivalent length of the accessories used. The first one is a valve with a strainer, a 90-degree angle, a pipe outlet, and a open gate valve. With that, we can get our total length of suction and our total suction losses. With both of them, we get the dynamic suction head, that is a 2.2 meters of water. Then we get to the impulsion. We need to determine a critical device, that is a shower on the second floor, and divide the system in sections. A critical device to node 1, node 1 to node 3, node 2 to node 3, and node 3 to the pump. We have the previously stated information based on our design, and we have to calculate the losses for each individual section with every device that they have. We use T's, we use angles, and we use reductions, as we can see here. These values change based on the number of devices in each section. With that, we get our total impulsion length, as we can see here, and our total losses, to finally get the impulsion head, that is 10.55. And finally, we can use the sum of these two plus our theoretical value or of pressure and a 1.15 security factor to get the value of the potency of our pump, that is going to be 1.6 horsepower.
About the distribution techniques, we have that if we have more than one floor, we can work in different parts. We can work in different worksheets, or we can work in just one worksheet when we include all the nodes in that worksheet. Also, we can get different divided nodes. That's because we have different intersections. Like in this example, when we in the node 1, we have two different subdivided. It is very important that the first node is the furthest one, so we can complement the lack of energy. And it is very important that we need to reduce that length to reduce the intersections and the lack of energy. Continue. And the accessories that we need to use are the angles. We have different types like the T, the 45-degree, and the 90-degree. This is very important to redirect the flow. We also have valves when we can control the flow of water if we need or we doesn't need it. And we have the pipe reduction when we can reduce the diameter of that pipe. Continue. We need to estimate different diameters, and it's very important how to do it. We can use formula like the flow rate is equal to velocity and area, or like the diameter that is the square root of 4 times the area divided by 5. It's very important that this is normated. We have the Flammer tables when we need to know the amount of element that we have, and we need to know the diameter of the pipe. And we can get the flow rate, we can get also velocity, and we can get about the losses. And in the normative, we have different criteria that the pipe needs to be more than 3/4 of inches, and the velocity rate needs to be about 0.6 and 2.5 meters per second. Continue. And about the design considerations, we have different considerations about different things. Like there is no big changes about the diameter that can cause different losses, and also we can disturb the flow of water. We need that the water pipe is full of water. There is no amount of air inside that. We need to avoid the erosion, and we need to avoid the sedimentation in the pipe. And also it is very common to use different materials like PVC or like copper. Okay, continue.
Okay, I'm going to talk about the reference price from construction chamber. The reference price is used from construction chamber date for the year 2023, as per the magazine shows also screen. This price are sourced specifically for warehouse and building construction. Next slide. The cost of plumbing materials and points of APP, the cost of half-inch polypropylene pipes is $5.65 per line meter, while a gate valve costs $35.56, and this price includes a corresponding lower cost. Additionally, we have 16 points of APP-X. The meaning is X point for public water supply. Multiplying this by the unit cost of $45.3 results in $724.80. The service connection has a unit cost of $6.78 per linear meters. The next slide, the cost of water pipeline and excavation, the cost of 3/4-inch cold potable water pipeline is $2.40. Excavation costs for earth movement are 1.73 per cubic meter, totaling 9.59 per cubic meter in our case. Machine excavation at 25 per hour is preferred for its efficient. In the next and the last slide, we have the cost of pumping system and pressure tank. The Pedrolo pump system costs 590 for a 1.5 HP horsepower and 110 volts. Additionally, a pressure tank price is 106.42 without installation and 590.14 with installation. Choosing appropriate pumping and pressure system is critical for ensuring reliable water supply and system performance and civil engineering installation. Thank you.